Hello, this is Lab 6, where you're supposed to design a comparator based on the 7486 chip, which includes 4 exclusive OR gates. And as you see here, we're going to use 3 of them. In your case, you have 2 numbers, each one made of 3 bits. And it's obvious that if the 2 numbers need to be equal, because you're going to be testing for equality only, right? And not greater than or less than. Therefore, they're equal when every pair of bits is equal, meaning the first bit of one number is equal to the first bit of the second number, and so on. And so this is why each exclusive OR gate will have 2 inputs, 1 bit from each number. And it's obvious that if the 2 numbers are equal, based on the exclusive OR gate table, that means every output of the exclusive OR gate would be 0, right? Because when the inputs are equal, the output is 0. In this case, I'm not showing what additional gate you need to use. Obviously, you need to consolidate the 3 outputs into one single output, so that as to visualize the result through an LED. It's obviously your responsibility to decide that. But in my case, obviously, the only case when they're equal is when the 3 outputs are 0. And so I'm going to use that to turn them into a single 0. And that 0, when applied to the output devices, in this case, the LED and the resistor, will light up the LED. You see here the configuration for the LED is different from the ones you have used in the past, because in the past you have used it to check whether the LED is on when the output is high. In this case, I want the LED to turn on when the output is 0. Why? Because when it is 0, it means all the 2 numbers are equal to each other, based on the discussion I had before. And so in this case, I'm applying the cathode to the output of the device and the anode to the positive of the battery. And it's clear that if the anode is 5 volts and if the cathode is low, obviously the 0 will lead to some voltage drop across the 220 ohm, but it's going to be low enough at the cathode so that the LED will turn on. And so in this case, that's what you're going to be using as part of your design. So in this case, as you see here, this is the circuit. I'm covering the chip that I'm using for the 3 input gate. Obviously, you don't have a 3 input gate, and that's why I gave you a drawing where you can use, at least that would be true for the AND gate, the OR gate, and the exclusive OR gate. When you use the configuration below, that means you take 2 of the inputs, apply them to one of the 2 input gate, then take the output together with the 3rd input, put them into another gate of the same characteristics, and the output would be equivalent to the output of the 3 input gate. The delays will be different, but at least as far as the logic is concerned, it's going to be similar. As far as the circuit is concerned, of course, I'm not using switches like I did in multisim, so I'm just using wires. And as you see here, I have chosen 3 different colors, 2 of them for the 2 bits from one number. Let's say first bit from first number and first bit from the second number. And I did the same with the yellow and green. And based on the choices that I made here, they're all high. I mean, not they're all high, but in this case, this is connected to a high, both of them connect to a high, and the green are both of them connected to low, which means the 3 bits have the same status from the 2 numbers, and that's why the LED turns on. If I decide to change one of the bits, for example, this, I'm going to connect it to a low, one to a high, the other one to a low. The other 2 pair of bits are equal, but these ones are different, so the numbers are not equal, and that's why the LED turns off. If I connect the other one If I connect the other one to a low again, I mean this comes off. Unfortunately, it came off, and one of the problems that I had with this breadboard is that the breadboards themselves are not connected properly underneath, right? The screws that are used to tighten to make sure the blades underneath are connected is not working properly. You have to change the breadboard. But in the meantime, what I wanted to show is that when the two are not equal, then the LED will be off. You see here I have to press on a breadboard so that it functions properly. So when the numbers are equal, the three pair bits are equal, it shows that the LED turns on, right? And whenever they're different, it will be off. Good luck with your breadboard, I hope.